Yeah, good day, guys. Welcome to our first class for probability. I've dubbed the introduction for probability only from mathematics, right? So let us first define what probability is. So we are saying it is a measure of a likelihood of a required or favorable outcome happening. So by that, it means we can therefore present it as an equation. We can safely say probability, therefore, is equal to the number of the required outcomes. So we are considering the required number of required outcomes over the number of the total outcomes. Right? So therefore, it means that probability has to range. It's a ratio. Therefore, it's ranging between 0 as a fraction to 1. So if as long as you are going to get a value, you are going to get an answer that is above 1. It means there is somewhere where you have made a mistake. It has to be between 0 and 1. Right? When is it 0? When the required outcome is actually inexistent. Like, for example, you are trying to find the probability of something that is not there. Then it is 0. The probability becomes 0. Right. So what about 1? When is it 1? When the required outcome is actually equal to the total outcome. That's when it is 1. Right. So I have prepared here some few questions that I want us to look into. But before we do, there are a few things that I want you to know that you are required to know by the syllabus. Number 1, you are required to know a die. Before you go into an exam, you are required to know these things. A die and its outcomes. You are required to know a coin and its outcomes. You are also required to know a pack of playing cards and their outcomes. Playing cards as well, you are required to know them. Let me first explain quickly a die. It's a cube. It's having its 6 faces, each face having a digit between 1 up to 6. So how many ones do we have on a die? In the real sense, we only have 1 ones on a die. How many 2s do we have on a die? We have only 1 2s on a die. How many 3s do we have on a die? Obviously, we have 1 again. Right, so each number is appearing once on a die. So whenever a question asks you, what is the probability of getting 3? It's obviously going to be 1 over 6. What is the probability of getting a 5? It's 1 over 6. So it's one common error that candidates may end up doing, to think that the probability of getting a 5 should be 5 over 6. No, it's not the case. It's 1 over 6 actually, because we are considering the required. How many are there over the total? How many digits do we have? So let us quickly then answer this question. Before we do, let me also just quickly highlight a coin. A coin is having 2 outcomes. It has a head, it also has a tail. Those are the outcomes on a coin. So it means probability of getting a head becomes 1 over what? Over 2. So I will explain the playing cards when we get to the question. I have also prepared a question for the playing cards so that we can also look at them. All right, so here is a question. He's saying a fair 6-sided die is thrown. Find the probability of getting a 2. So what then shall be the probability of getting a 2 on a 6-sided die? Of course, how many 2s do we have? It's 1 over 6, the total outcomes. That becomes the probability of getting a 2. How about the probability of getting a prime number? Let us first define what a prime number is. So this is borrowed information from natural numbers, one of our first topics that we have. So from natural numbers, etc., real numbers, integers, everything. So a prime number, by definition, it is a number that can only be divided by 1 and itself only. A number that is exactly divisible by 1 and itself only. Please do take note, 1 is not a prime number. So among the numbers, we have 1, 2, 3, 4, 5, 6. These are the outcomes of the die. The question is asking us, what is the probability of getting a prime number? How many prime numbers do we have? Mind you, we said 1 is not a prime number, so we are starting at 2, 3, as well as 5. So how many do we have? We actually have 3 over 6. Reducing that to the lowest term, we end up having 1 over what? 1 over 2. So it's half. just like that. Okay, then what is the probability of getting perfect square? How many perfect squares do we have? Again, we are checking among our numbers, among the numbers that we have, how many perfect squares do we have? We actually have 1, we have 4. These are perfect squares. So 2 over 6. Remember, just out of interest, a perfect square by definition is a number whose square root is a whole number. So for as long as we are talking of a number that if you find the square root is going to be a whole number, 1, 4, 9, 16, 25 as we go, those are examples of perfect squares. So between 1 and 6, we only have 2 of them. So reducing this to the lowest term, 2 over 6 is going to give us what? 1/3, meaning to say our probability is a third. Then what about the probability of a 7, getting a 7? Right, the probability of a 7. Do we have a 7 between the numbers from 1 to 6? We don't. So what does that mean? That's now the example we were giving, saying when is the probability 0? When the required outcome is inexistent, when it is not there, like right now, we don't have a 7 among the numbers between 1 and 6. So it's 0. That's the probability. So let's quickly jump to the question on the coin. So the question for the coin is saying a coin is tossed to find the probability of getting a head. So we said, how many outcomes do we have on a coin? We actually have 2 outcomes, a head and a tail. So how many heads do we have? We have 1 over the total 2. A tail, 1 over 2. So that's how you deal with a coin. That's how you answer a coin. By the way, just to digress a little, we are saying, why is the coin called a head? Has its faces as a head, a tail? Usually, a long time ago, it used to be known that coins were having a head of either a king or a queen on them. So they always said that the side that where the head is, that's the side which was called the head. Then obviously the other side became the tail. So that's basically how the coin is. We should also take note of it as we go into as we prepare for the exams. That is one of the questions that are also might pop up. We need to know that. All right, let's go to the pack of playing cards. Right, I will use this question to try and explain how questions on playing cards. How do you deal with playing cards? Number one, there is some information you need to know regarding playing cards. Regarding playing cards in general, you need to know this information. Right, it's having these outcomes. Right, number one, a pack of playing cards consists of A, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then it has what are called court cards or face cards, Jack, King, and Queen. These are called court cards or face cards. Right. If you check, all of them are 13. Look at this one. They are 13, all of them. Now, each of them has a heart, has a diamond, has a spade, and has a club. The club is also called the shrubs. We can call them shrubs, but they are normally known as they are actually known as clubs, right? Those that have a picture that almost resembles a leaf. They almost resemble a leaf. Then there is the spade, and then there is the diamond, which actually has a diamond as sign, and then the heart, which actually has a heart sign, right? These first two here are red in color. These ones are black in color. But what we need to mark is an ace has a heart, a diamond, a spade, a club. A 2 has a heart, a diamond, a spade, a club. So which means how many cards do we have written 2? They are obviously going to be 4. How many do we have written ace? They are actually 4. A heart, a diamond, a spade, a club. How many cards do we have that are written 3? They are 4. So all in all, if you check, they become 13 times 4, that makes them 52. So in other words, we are saying a pack of playing cards has 52 cards. So if you can master, if you can understand this explanation that we are giving right now, you are good to go with the cards. So we are saying there are 52. Mind you, if you try to go and buy a real pack of cards, you will not find them being 52. As a matter of fact, they are actually 54 because there are some bonus players there that the jokers they are regarded as bonus players. So we don't regard them when we talk of playing cards, right? So now, how many red cards, by the way, do we have from this explanation that I'm giving? It means the red cards are, we have hearts, 13 of them. We have diamonds, 13 of them. They are red. 13 plus 13, that makes 26 red cards. Black cards, 26 as well. So in rows, we have hearts. In ace for a heart, a 2, a 3, a 4, which means there are 13 hearts, 13 diamonds, 13 spades, 13 clubs. That's the order of the playing cards. So let's go quickly into questions. Mind you, do not forget that we have the court cards or the face cards. These are court cards or face cards. So let's quickly go to questions now that we have this information, right? So the first question is saying, a card is picked from a deck of playing cards. What is the probability that the card is a 2 of spades, right? So from the look of things, if the question had just said a 2, we have 4 twos, a heart, a diamond, a spade, a club for twos. But then the question is saying specifically a 2 of spade. We want a 2 of spade. We only have 1 2 of spades, because among the spades we have an ace, we have a 2, a 3, a 4 spades, which means 13 spades all in all, but we only have 1 2 of spades. So for that reason, we are simply saying our answer is 1. Remember, favorable or required outcome over the total. How many are they? 52. So we have answered that question. What is the probability of getting a court card? Let's go back to the court cards. We were saying, how many court cards do we have? Jake, we have 1, 2, 3, 4 jacks. A heart, a diamond, a spade, a club. Similar with the king again, there are 4 of them. Similarly, it's also true with the queen. There are also 4 of them. So how many all in all do they become? They become 4 times 3, which makes them to become 12. So the court cards are actually 12. So we can safely say 12 over 52. Reducing that to the lowest term, the common factor we can use is 4 into 12 is 3, 4 into 52 is 13. So it's 3 over what? Over 13. Right. Lastly, the question is saying, okay, last but not least, either a 4 or a 5. A 4 or a 5. So what do you do when you have such a question? How many 4s do we have? Maybe we've all come to notice that for 4s, there are 4 4s. There are also 4 5s. So we can just say 4 over 52 plus 5 over 52. So I want to use this question to emphasize on the fact that whenever we say either or, we use the addition rule where we are now adding the two outcomes that we have, 4 over 52 plus 5 over 52. So plus 4, sorry. So this is going to be 4 over 52 plus 4 over 52. Pardon that. It's 4. Why? Because we are saying how many 4s do we have? How many 5s do we have? We have 4 5s. Heart, diamond, spade, club. How many 4s do we have? Heart, diamond, spade, club. So both of them are 4 4. So for that, we are saying 4 over 52 plus 4 over 52. That is going to give us then 8 over 52. Reducing then to the lowest term, we are going to get 2 over 13. So this is going to give us 2 over 13. Okay, so that's 2 over 13. Okay, right. So regarding playing cards, I'm going to leave this question to us a red queen. A red queen. We are checking among all the queens. How many are reds? you notice that there are only two red queens. Two red queens. A red queen, there are supposed to be two of them. So it's simply 2 over 52 reduced to the lowest term. We are going to get 1 over 26. Okay, quickly, therefore, I'm just going to go to this other question of balls that are in a bag. Right. A random pick of balls in a bag, if we pick one, the probability becomes, as usual, required outcome over the total outcome. So a bag contains 2 red balls and 3 white balls. What is the probability that a ball picked at random is a red ball? Right. How many red balls do we have in the bag? That's 2. Over how many balls all in total do we have? 2 red balls plus 3, 2 plus 3, that makes them what? 5. So red balls 2 over 5. A red or a white, 2 over 3 plus how many white balls? 3 over 5. So this example is almost matching the one that we made there at 3.3D. That's the same idea that is happening. So we are simply going to add, but then the required outcome is now equal to the total outcome. Then obviously, if such a situation happens, it might save you time to quickly note that it's obviously going to be 1. Then a blue ball. What is the probability of picking a blue ball in a bag that is having red and white balls? The probability is 0. This is basically what is happening. So this is what we have to mark. By the way, examples we are citing, we're doing right now are of what is called theoretical probability. So do take note of that. That's what is happening on probability. This marks the first part of explanation of probability. Do take note of the other part for outcome tables and tree diagrams, where we want to explain outcome tables and tree diagrams. Okay, so if you haven't subscribed, just do subscribe and turn on the notification bell, so that if ever we upload any videos that are going to be helpful, you can also access them. Okay,